In this video, we will explore the new io.jpostman-secure module, introduced in jpostman release 1.0.2. You will see how this module makes secure API testing easier, and why it can be more convenient than using only the core request and ApiResponse classes. Let's open the pom.xml file and update our project dependencies. First, we will add a property section to define the Java version, Maven compiler release, and project encoding in one place. Now let's organize the dependency versions. We will move each version number into the properties block and then reference those properties inside the dependency definitions. This keeps our version management cleaner and easier to update. Lastly, we will add the new jpostman-secure dependency to the pom.xml file. After updating the dependency list, right-click inside the POM editor and select Maven Update Project and click OK in the Update Maven Project window. Now let's run the same demo from the previous lesson again. As you can see, the console output includes sensitive information, such as the access token, refresh token, and user email. For better security, we should avoid printing these values in the log output. Before we update the request execution, let's import SecureContext and SecureRequest. Then, we will call the createFactory method from the SecureContext class and define a variable named Secure. Now let's convert the login token request to use the Secure module. We will replace request with SecureRequest and wrap the original collection request by calling secure.from function. Now, the login request is protected when printed, so we can temporarily add a print statement to confirm the output. Since the executor returns an API response, we will wrap the entire executor call with secure.from. This converts the regular response into a protected secure response. After running the test with Ctrl plus F11, we can see that sensitive values are now masked in the console output. The response hides the access token and refresh token, while the response output hides the password field. These are default protection rules provided by jpostman, and later we will review how to customize them. The user email should also be protected. To handle this, we can call the redact function from SecureContext and pass email as the field name. After running the test again, the email value is masked in the console output. Request and response logs help troubleshoot failed tests, but they may contain sensitive data. With masking, we keep useful details while hiding protected values. To demonstrate this, let's change the expected status code from 200 to 400 and remove the print statement below. After running the test, we get an assertion error, and the failure output still shows the response body with protected values masked. To print the request and response safely, we can use secure.log false and skip the response headers. The console now shows both the request and response details with sensitive values masked. We can troubleshoot the failure without exposing the password, tokens, or email. The second request needs protected types as well. We will wrap the request and response with secure.from and replace request and API response with SecureRequest and SecureResponse. SecureContext can store key value maps as protected or plain data. This lets us set the environment once instead of passing env into every request build. Let's compare both options, starting with secure.plain env. As you can see, secure.log false displays the original placeholder variables inside curly braces. This is useful for debugging because it shows which fields may not be resolved correctly. Next, we will remove the false flag and compare the output. Calling secure.log resolves all variables. Because we added the environment with plain env, those values remain visible in the console output. Also notice that log prints the request and full response body and headers, while protected keys, such as set cookie, are still masked. I will replace plain env with secret env and run the code again. This treats the Postman environment variables as protected data, so they are automatically masked in the console output. Let's review another option for masking protected data. In this example, I want to protect the Etag response header, So I will add .headers, Etag, to the SecureContext setup and run the code again. The Etag value is masked, but the response includes many headers, and most of them are not needed. To make the output cleaner, I will add headers filter, date, so only the server date header is displayed. Perfect. We can now see that sensitive data is masked in both the request and response, while the header output is limited to the date header. This makes the failure log safer to store in a log file or cloud platform. The first request can expect status code 200 again. For the second request, I will replace resuser.pretty with secure.log in the assertion message. In the next step, we will run the test and review the printed output. I will start with request.print and pass false to review the unresolved request with its original placeholder variables. Then, I will call print with the default resolve option. Sensitive data remains masked, but I will allow the base_URL to be visible. The recommended approach is to manage environment values with plain and secret. In Release 1.0.5, jpostman also introduced unsecret, which lets selected values remain visible. We can use it here to show base_URL in the demo output. After running the project, the full URL is visible as expected. To continue the inspection, we will replace request.print with resuser.print, so we can review the response data. The response contains many sensitive fields that should be protected. Instead of adding each rule through SecureContext, we can use a new rule policy template, introduced in Release 1.0.5. The link is shown at the top of the slide and will also be included in the YouTube video description. To clean up the SecureContext setup, I will remove the individual rules from the code and keep only .secret env. This allows the environment values to remain protected. Next, I will right-click src/test/resources in the Project Explorer, select New File, enter a new file name with the .ini extension in the Create New File window, and click Finish to create the policy file. I will move the removed rules from the source code into the policy file. Since these keys are common across request and response data, I will define them under the default section. The matching fields are highlighted in yellow in the console output. For the second response, I will define a user section that extends the rules from default. Since I only want to show the country code highlighted in cyan, I will add a slice rule for the phone field to hide everything after the first 3 characters. As I continue scrolling through the response, we can review the additional fields. First, I will hide only the user address using path segment matching. Then, I will hide the user details highlighted in red and the entire hair block using path-based rules. The next rules will protect MAC address and location coordinates. The stars pattern matches coordinates at any level in the response. For the credit card number and bank IBAN, only the last 4 characters will remain visible. The coordinates are already protected by the previous path condition. We still need to protect SSN, user agent, and the crypto block, so I will add entries for those fields. To apply the policy file, I will load it from the resources directory using getResourceAstream and pass the .ini file name. This loads the global rules first. Before the second request, I will update the secure variable by applying the user section. After execution, let's review the response output. As we scroll, the sensitive information is masked, and the result contains fewer lines because some node data is truncated. If a server error or exception occurs, this output is safer to store in the logs. To reduce the response data further, we can apply filter rules at any time. Here, I will filter the output by ID, first name, last name, and gender, and run the test again. In a future video, we will review Vault, Kubernetes config map and secret, and GitHub environment support in jpostman. Thank you for watching. In the next video, we will continue reviewing more jpostman features. I also recommend visiting the jpostman wiki page for additional details and examples related to this tutorial. Thank you, and happy testing.